Hello and welcome to the video. This video is about this thing here. This is the ZOHD Drift. Now, I looked at this a couple of years ago and was a big fan of the way it flew. However, it's just not getting flown, and the reason for that is the all-in-one camera that's in the nose that came from ZOHD. It's really poor quality. And as we fly more and more HD in the hobby now, and I'm used to cameras with much higher resolution, better dynamic range, this just wasn't a great camera. So consequently, it's sat in the garage and hasn't really been played with. Now, I've updated a number of my models to the Walksnail HD system. Specifically, it's in the nose now of my Atomar Dolphin, one of my favourite models of all time, and that is working incredibly well. And I also installed it in the nose of the Swordfish as well. And that Swordfish is another great flyer. So I was interested in resurrecting some of the older models, things like this ZOHD Dart XL, for example, to review them and look at them through the lens of the modern hobby. Because these have both been around for quite a long time, and ZOHD seem to have just stopped making new stuff. Now, the big thing that happened recently was that Walksnail released the 1S avatar unit, the updated version, designed specifically for Whoops and 1S setups. And I've been mulling over for quite a few weeks, could that be installed inside something like a Drift, which hasn't got a ton of space inside, and give myself a HD Walksnail Drift that would fly great. So in this video, I just want to show you how I've done this. There is going to be another video doing a full review of the Drift through that modern lens of the hobby, because I had to do a little bit of thinking here to get the Walksnail system, this 1S Walksnail Whoop system essentially, inside a plane in a way that I was happy with. The HD system itself only weighs 2 grams more than the all-in-one setup that it's replacing. However, I did then add a heatsink onto it because it is hidden away a little bit. There is airflow from the nose. That additional 3 grams had to be kind of offset on the tail with a little tiny weight of 2 grams to get everything absolutely spot on. So the overall model now weighs 270 grams with the Walksnail system versus 272 grams with that terrible analog system. So that's about a 2.5% increase in weight, and you'll see how it flies soon. So let me go through the installation and my thoughts on this. Now, the smaller camera fits perfectly into the nose, so I don't need to worry about that. That's going to be quite easy. The board itself is designed for a Whoop and to go inside a Whoop, so I need it kind of vertically on its side, and initially I was trying to figure out where that would sit, and I even had a thought of maybe mounting it outside of the body in airflow to help keep it cool, but it's just in a place where it's potentially going to get hit and full of water and mud and who knows what else. I also need it very far forward, well out of the way of the battery. The battery in this that I'm using, an 853S pack, needs to be right at the back, so it just gives me a little bit of room at the front. However, I don't want to be constantly hitting it with a battery as I'm taking it in and out. So I ended up cutting a little bit of a recess here at the front so that the board could be as far forward as I could get it. And I'm using the rubber mounts and some of the M2 screws in the corners to hold it in place and also to hold it off the foam so that there is that little bit of airflow behind it as well. Now, placing the board here at the front allows me to run the antenna up through the normal antenna hole, but also it means that the cable that's relatively short on this 1S avatar unit allows me to get that with the camera in the front as well. Now, the other thing I had to think about was how I'm going to power this. Now, this only runs on a 1S battery. This is a 3S model. So how am I going to make that work? Well, the trick here is that what I'm going to do is I'm actually going to cheat a little bit. And because this is a very low amp draw from this battery, I'm going to do something a bit risky. And I'm actually going to connect the 2 leads that are going to power the unit across the first cell only of the 3S battery. So what I've done is I've got a balance tap on these JST connectors, and I'm just going to solder the 2 power wires over these 2 outside pins, where the black wire is for the battery, and also the next one along, which is the connector for the next cell. So I'm just taking the single cell voltage that's actually going to run this thing. Now that does mean that the first cell is going to be working a little bit harder than the rest of them in flight, and I'm going to have to balance the battery afterwards, but this is a way for me to keep the weight really nice and low and not to have lots of extra battery eliminator circuits and kind of things to manage the voltages, and I can just use this trick to get that 1S from the 3S pack. This is how it looks when it's installed. It's here at the side. I have also 3D printed a couple of nuts, I guess you'd call them, M2 nuts that are in the side here. They're a slightly weird shape. That's because the one at the bottom is very hard to get to. It kind of naturally keeps itself into position. And I've also added that heatsink. This unit does run quite warm. I think Walksnail initially intended to ship this with a heatsink, and in fact my review unit initially came with a heatsink on, but they asked me to remove it for the video. So I'm putting this nice chunky unit on here. There was a couple of options for the heatsink. These are the kind of things that you'd normally put on stepper motor drivers, but this should make sure that it manages okay in flight. Only one other big trick here. Now, because we have this installed in a way that it isn't connected to a flight controller, the Walksnail system isn't going to be told by a flight controller that the system is armed. That means that it doesn't go to full power. So what we need to do is you need to go into the menu in the goggles, and you need to then turn off standby mode manually, and that will immediately take the system to full power. Now that's only something that's set avatar by avatar unit, so it isn't going to affect the other ones in your model. And the way I've set it up here is that I can power the system of the co-pilot that's already in here with the GPS, let that get a lock and be ready to fly, and literally the last thing I do before I chuck it is then plug the Walksnail unit in and then put the battery hatch closed, and then I can chuck it and use the auto launch feature. Now, doing it this way, of course, means that at the end of the flight, the first cell in the 3-cell battery that I'm using is lower than the rest, and that isn't ideal. It's putting a lot of stress on the battery, but this is a very easy way to do it without any other extra electronics. However, my buddies and I have been flying it here and having a whale of a time with it, and I would prefer for the whole battery to be used to power the Walksnail unit. Now, the Walksnail unit itself is capable of running from just over 3 volts to 5 volts. It's designed to go into a whoop. But I've decided that what I'm going to do is use these things here. This is a Maytech 5 volt BEC. It's the size of a fingernail. And I'm also going to use a little trick using a diode to drop some additional voltage, because I don't want to run the Walksnail unit at 5 volts. I'd rather it was a little bit less, because let's be honest, it's kind of designed for a 1S system and I don't want to stress it. So first thing I did, I connected the diode as shown here. So that's the voltage out pin, and it turns around so that I can connect the voltage pin to the avatar unit here. And then I hot glued it onto the back of a balance tap, and then connected the outside positive and negative wires into the input of the Maytech power distribution board. Then connected the black and red wires onto the ground and the other side of the diode, and then put a bit of heat shrink over the whole thing before adding a couple of dabs of hot glue for strain relief and covering the whole thing in this covering here. Now, the great thing about this is that that diode, as the current flows through it, will actually drop a little bit of voltage. The diode that I'm using here drops 0.9 volts. So in the goggles when I'm flying, it now reads as 4.1 volts, but the entire battery is being used. And that's a slightly better way of doing it, because it now means that rather than stress a single cell and potentially limit my flight time as that cell goes down, I'm using the entire battery. The thing I've sacrificed is that rather than being able to monitor the cell voltage in the first way that I did it, I can't in this way, because it's always going to be 4.1 volts out of this 5 volt BEC, with that extra little 0.9 volts being dropped through that diode. So I'm going to have to watch my flight times. But keep your eyes open. I am going to be doing a full re-review of this model with the Walksnail system in, but I'm pleased to report it's running absolutely great and not getting overly hot thanks to that heatsink. Thank you for spending your time today watching that video. You can find me in all the usual places on social media, and if you're trying to learn about a subject, then check out the playlist. All of my videos are organized into easy to follow playlists that, if you're trying to learn a topic, will take you from the basics right the way through to some pretty advanced stuff.